Okay, this is the first video of graphing functions retest review, graphing exponential functions, graphing logarithmic functions, and graphing inverse functions. So if we look at our first example, we have an equation, right, that we know that this is an exponential function. The transformations that have occurred here, we have moved to the right 4 units, and we have moved down 2 units, right? This x minus 4 is telling me about moving to the right. This minus 2 is about moving down. I know that this 2 right here represents my base. All right, so this is an exponential function. And in general, the basic shape of the graph that I would expect to have is an exponential growth, but this particular graph is going to be moved up and it's going to be moved down. All right, so what's the domain? The domain is going to be all real numbers. What is the range? The range is going to be y greater than -2. What's my asymptote? Y equals -2. And what's my end behavior? Well, my left end behavior is going to be y approaching -2, and my right end behavior is going to be y approaching infinity. And that's because on the left side of the graph, right, we're going to have our function that has moved down by 2 units, and so we're going to have a left end behavior towards -2, and the right end behavior, once I move to the right, is going to be going up towards infinity. All right, so if I want to sketch the graph, I can think of my specific points. Right, the specific points that I generally have will be the point 0, 1, and the base 1, and then I can say the base to the base to the second power, right? So the base to the first power, excuse me, let's correct this. Right, that if x is equal to 1, then I'm going to have my base. If x is equal to 2, I'm going to have my base to the second power, right? If x is equal to 3, I'm going to have my base to the third power. But that is the general form if I just had my exponential 2 to the x. Right, so the point 0, 1 is going to move to the right 4 units, so 1, 2, 3, 4, and down 1 unit. The point 1, 2, right, at 1, 2 is going to move to the right 4 units and down 1 unit. The point 2, 4, so 2, 4 would move to the right 4 units and down 1 unit. The point 3, 8, right, so if I had the point 3, 8 to the right 4 units and down 1 unit. Okay, I know that I have my asymptote at y equals -2, and I know that I have the general shape of my graph, right? And I can say, hey, what about this y-intercept if x is equal to 0, right? I know that I have the general shape of my graph is going to be coming up in that form. So there I have my exponential function that was moved to the right by 2 units, or excuse me, moved to the right by 4 units and moved down by 2 units. All right, and so actually we do have this incorrect because it's going to be moving down by 2 units, not by 1 unit. So let's refresh this. So the point 0, 1 is going to move to the right by 4 units and down 2 units. The point 1, 2 is going to move to the right by 4 units and down 2 units. The point 2, 4 is going to move to the right by 4 units and down 2 units. The point 3, 8 is going to move to the right by 4 and down 2 units. And so there we'll have the better form of my graph. So you want to be careful about plotting your points and getting the correct graph. If we look at another example, for this one, we have 3 times 2 to the negative x plus 4, -5. And so once again, 2 to the x is going to be my base. So I have a vertical stretch by a factor of 3. I have a shift left by 4 units, and after shifting left by 4 units, then I have a reflection in the y-axis, and then after shifting left by 4 units and then reflecting in the y-axis, lastly I move down 5 units. Right? Once again, this is exponential. All right, and if I think about this particular graph, this was exponential growth to begin with, but then I moved to the left and I reflected the y-axis, and so I know that if I move to the left, right, this point moves over here and then reflects in the y-axis, right, everything's going to kind of change, and my graph will end up looking a little something like that, and it's going to then go down by 5 units. So my domain is still all real numbers, and y is greater than -5 is my range. My asymptote, y equals -5. All right, and if I look at my left end behavior, on the left end, which would be the left side, y is approaching infinity. In the right end behavior, which is the right side, y is approaching -5. So I can come in and sketch my graph, y equals -5, and I can plot my particular points, right? So I know the point 0, 1 is one of my points. I know 1 times the base is another point. I know 2 times the base squared is another point, and I can think about what's happening to each of those points and what's happening with the reflections. But of course, I could also just put numbers in for x and figure out what I'm going to have. So let's say x was equal to 1. That would be 2 to the third power, right, which is 8 times 3, right, minus 5. If x was equal to 2, right, I could do a little t-chart as well. That's what we're saying, right? I could say, hey, what if x was equal to 2. If x was equal to 2, I'd have 2 squared, -2 plus 4, times 3, that's 12 minus 5, that would be 7. So I'm going to have the point 2, 7 as one of my points. Okay, then I could say, well, what if x was equal to 3? If x was equal to 3, that'd be 2 to the first power. I'd have the point 3, 1. Right? If x was equal to 4, that'd be 2 to the 0 power, that's 1. So that'd be 4, -2. So at 4, I'd be at -2. If x was equal to 5, that'd be 2 to the negative first. That'd be like 3 times 1/2. Right, and 3 times 1/2 would be 1.5 minus 5. I know that that would give me, let's see, 1.5 minus 5. That would be to the -3.5. So I'd be somewhere down here, and so my graph for this would look a little something like that with the exponential decay. All right, continuing with our graphs. We have our graph for a logarithm, right? And we can say, well, what's happened with this particular function? We've moved to the left 5 units, and we've moved down 3 units, right? So what's going to happen with my asymptote? My asymptote has moved to the left by 5 units, so that's now going to be x equals -5. I know the general shape of my graph is going to be looking like that. So my end behavior, I'm just going to have a right end behavior, and that's going to be y approaching infinity. Okay, and if I look towards this one, I have a reflection in the x-axis because of this negative. I have a vertical stretch by a factor of 3 because of the 3 multiplied in front, and I am moving up by 2 units. So I know that the general shape of that graph, because of the reflection in the x-axis, is going to be a little something like that. I did not move to the left or the right, so my asymptote is still x equals 0. And my end behavior, once again, I only have a right end behavior, and I'm going to have y approaching -infinity. Right? So then I need to plot a few points for what my graph is going to look like. So I can come in and I know that I have my asymptote x equals 0 for this one. I know I have my asymptote x equals -5 for that one. And if I come up and I say, okay, well, what if x was -4? If x was -4, so xy, if x was -4, that'd be net log of 1, which is 0. So I'd have the point -4, -3. So -4, -3. If x was equal to, let's say, -3, that would be log of 2, which would be 1, minus 3, that'd be -2. So I'd be at -3, -2. If x was equal to, let's say, -1, if x was -1, I'd have log base 2 of 4, which would be 2 minus 2, that's -1. So I'd be at -1, 1. If x was equal to, let's say, 3, then I'd have log base 2 of 8, which is 3 minus 3, that's 0. So now I have the point 3, 0. And so then that generally gives me my graph of my logarithmic function. Okay, and if I look to the next graph, I can do the same thing on, thinking about, hey, what are some x, y coordinate points to try out? So if I had 1, log of 1 is 0, times -3 is 0, plus 2, so now I have the point 1, 2, so 1, 2, right? If I had 10, okay, well, log of 10 is 1, times -3 is -3, plus 2, that's -1. So I know at 10 I'm going to be at -1. And this has my exponential decay, or not exponential decay, rather, my logarithmic decreasing function that has the general shape that I was expecting to have. So those are graphs of exponential functions or transformations and graphs of logarithmic functions. In the next video, we'll talk about graphs of inverses.